Hi everyone, this is Tao Lu from the University of Michigan. This work was conducted with my co-authors Hongxiao, Tianying Zhang, Xuhai Xu, and Professor Anhong Guo. In this video, I'm very glad to present our work, InteractOut, leveraging interaction proxies as input manipulation strategies for reducing smartphone overuse. Smartphone overuse poses risk to people's physical and mental health. However, current intervention techniques mainly focus on explicitly changing screen content and often fail to persistently reduce smartphone overuse due to being over-restrictive or over-flexible. Strong interventions force users to stop usage by blocking the phone and setting the hard task to unblock, which are often too annoying and disruptive. On the other hand, soft interventions provide subtle reminders that are carefully designed in psychology and social science, but they can still be easily ignored or dismissed. The smartphone user decision-making process can be largely explained by dual process theory. To engage users, app designers often try to cater to one's desire for immediate gratification and override their logical thinking. Users often just need to use simple tap and swipe interactions. Conversely, research shows that harder or more sophisticated interactions help evoke users' self-awareness. These shed light on our idea of manipulating input to introduce a mismatch between the issued command and the output on the screen. We present the design and implementation of InteractOut, a suite of implicit input manipulation techniques that leverage interaction proxies to weakly inhibit the natural execution of common user gestures on mobile devices. InteractOut presents a design space of continuous and discrete manipulations on 4 properties, including time, location, direction, and the number of fingers. We further propose 4 intervention strategies, including shift, complicate, extend, and disable. We then demonstrate 8 Android implementations of input interventions throughout our design space, including tap delay that postpones the time for users' tap to take effect, tap prolong that requires finger to stay on the screen for a longer period of time in order to single tap, tap shift that shifts the tap position away from the actual tap position, tap double that requires double tap to single tap, swipe delay that postpones the time for user's swipe to take effect, swipe deceleration that extends the replay time of user's swipe, swipe reverse that reverses the direction of user's swipe, and swipe multiple fingers that requires users to use more than one finger to swipe. Along with 5 remaining interventions our design space affords, such as lock and unlock, and other disabling interventions. We instantiate InteractOut as an application on Android system. The left figure shows a case when users operate the phone normally. InteractOut inserts a proxy layer between the screen and the application layer. The proxy layer first consumes and recognizes user input gestures. Then, it uses the gesture information to build virtual gestures. Finally, it passes the virtual gestures to the application layer. We first conducted a pilot lab study with 30 participants to evaluate the usability of different InteractOut implementations on 2 intensity levels. We chose X and Bubble Mania, 2 popular and addictive apps, which represented apps with swipe-heavy and tap-heavy interactions to mimic realistic smartphone usage scenarios. Participants preferred tap delay, tap shift, swipe delay, and swipe deceleration. Other intervention techniques such as tap prolong increase the error of manipulation, which is very disruptive to the user experience. These 4 preferred techniques create a higher mental load but a lower physical load, preventing participants from diving deep into the content, since it takes longer for recommended information to come. Participants said they would rather put down the device and focus. and participants tend to prefer higher intensity level for most interventions. Lower intensity level are not that effective. For example, P21 said 500 millisecond delay was too short that they could not even tell if there was intervention or not. And P4 mentioned they need to put extra effort to successfully tap on the screen when it's 200 milliseconds prolonged compared to 100 milliseconds. We then conducted a 5-week within-subject field experiment with 42 participants to understand how InteractOut influenced smartphone usage and user receptivity in real-world scenarios. The first week was used to measure participants' usual smartphone usage without any intervention, followed by two 2-week intervention stages, each including 12 intervention days and 2 break days. The break days were inserted to investigate the lasting effect of interventions and to reduce the influence between interventions. In the onboarding session, participants installed our app, learned the features of their assigned gesture interventions, and specified the target apps to apply screen time interventions. During the experiment, we logged the app enter and exit events, as well as instances of intervention encounter and bypass on participants' device throughout the study. We also delivered in-study surveys to collect workload using NASA TRX and subject feedback on 2 interventions. At the end of the study, we conducted an exit interview for each participant for their overall perception of 2 interventions. We compared InteractOut against one of the most common intervention methods, the timed lockout intervention, in which users are locked out of the app when the time limit is reached. We first investigate app usage behavior, the usage time, and opening frequency. Due to the large app usage variation among individuals, we normalized each participant's data by calculating the ratio against their own data during the base week when there was no intervention. Results showed that both InteractOut and lockout significantly decreased participants' target app usage compared to their naturalistic usage. InteractOut significantly reduced the usage time by an additional 15.6% compared to the lockout. We observed similar results for opening frequency, where InteractOut reduced smartphone usage significantly more than lockout, with an additional 16.5% on participant-selected target apps. InteractOut also achieved a 25.3% higher user acceptance rate and resulted in less frustration and better user experience. In addition, we measured the subjective workload of the interventions using NASA TRX questionnaire in our weekly in-study surveys. Expectedly, InteractOut had a higher overall workload than lockout. InteractOut was more acceptable than timed lockout. First, it intervenes with appropriate flexibility. As P26 mentioned, it allowed them to complete their current tasks, such as reading a news article, which is more comfortable. Second, it provides user agency. P25 told us that InteractOut slowed down the app, and they started to think if they want to use the app anymore. And they feel like they don't need it and they will stop. Users are making their own decision in this process. Third, it's always on. P21 said when they use the app during the InteractOut interventions, they found they do not like using that app, whereas the time lockout did not change how app works after they ignore the limit. Finally, it introduces a gulf of gratification. For example, as InteractOut slowed down the scroll speed and made scrolling not in real time, participants like P39 lost interest of the app, as it became difficult to gain gratification from the app. Finally, I want to share 2 most interesting discussion points of our work. First, the compatibility and the complementarity with existing interventions. InteractOut could be seamlessly integrated with existing explicit interventions, such as timed lockout. InteractOut also exhibits compatibility with implicit techniques, such as reminders and user experience manipulations. Such compatibility and potential for synergy offer researchers, developers, and users a promising pathway to more effectively manage smartphone usage, while maintaining a user-centered approach to intervention design. Second, in the future large-scale longitudinal deployments, users should have user-defined intervention configuration and personalized InteractOut. Future work could investigate the potential of making interventions intelligent and adaptive based on AI models to detect risk behavior with sensor data, moving towards a vision of just-in-time adaptive intervention. We could also extend our exploration to certain app-specific feature-level interventions to augment user receptivity and enhance the overall effectiveness of the intervention strategy. Moreover, it is promising to see input manipulations beyond smartphones. We can apply similar intervention designs to devices with different modalities, such as desktop and even in the future, AR/VR devices. These future research directions with large-scale deployments not only enrich our understanding of multifaceted potential of InteractOut, but also contribute to the ongoing evolution of input manipulation-based intervention methodologies. To summarize our work, we introduced InteractOut, a novel set of implicit input manipulation strategies for smartphone overuse intervention. We present the design space of input manipulation that weakly inhibits the natural execution of common user gestures. We further conducted a 5-week deployment study with 42 participants in the wild. Our result demonstrates significant advantages of InteractOut over the common timed lockout intervention on smartphone usage time, opening frequency, user acceptance rate, and subjective user feedback. Most importantly, InteractOut introduced a new perspective of smartphone overuse interventions that can be compatible with and complementary to existing intervention techniques. That's all of my presentation. Thank you for listening.